In our last set of notes, we learned how if we had a number added after a parent function, that it moved it up the graph, whatever it is, up and down. And if we had one added or subtracted inside, it moved our graph left or right. So that moved it around. So today we're going to ask what happens when we multiply a number times our parent function. So here we're going to work with absolute value of x. I've got 0, and I plugged that in and got these, which I hopefully have memorized now, and graphed it right there. So here's the graph of y equals the absolute value of x. So now we're going to 2 times the absolute value. So 2 times 0 is 0. 2 times 1 is 2, 4, 2, and 4. And we're going to graph it. So we have 0, 0 again. We have 1. This time we have 2, then 2, and then 4. Is that right? Yeah. And then we have -1, 2, and -2, and 4. So you see, when we connect, we get something that looks like this. So what happens? It appears when we compare the two graphs that the graph is getting tall faster. So I'm going to put that getting taller faster. And how did our basic ordered pairs change? Well, it looks like the y's or the x's stay the same. So x stays the same. While what happens with the y got multiplied by 2. So multiply y by 2. All right, so in general, if we have a function, so just f of x, so y equals f of x, if we multiply a times whatever that function is, that's going to be what we're looking at right now. So for any equation like this, what do we do with the a? We're going to multiply a times every y value while the x stays the same. All right, so let's give it a try here. So I have y equals 3 square root of x. So what's the parent of this? Okay, good. The parent is the square root of x, right. So when we do the parent, we're going to have a 0, square root of 0, 0, 1, square root of 1 is 1. We don't want to do 2 or 3, so we'll put a 4 in. Square root of 4 is 2, and we can't do negatives. All right, so now we want to do 3 times the square root of x, so that's going to give us 3 times 0 is 0, 3 times 1 is 3, and 3 times 2 is 6. So we're now going to graph the ordered pairs. Here's going to be my x's here, and here's going to be my y's here. So we're going to graph those points. So we have the point 0, 0, 1, 3. So I'm going to go over 1 and up 1, 2, 3. And the point 4, 6. So over 1, 2, 3, 4. And up 1, 2, 3, 4, 5, 6. So we know what the general graph of the square root looks like. So we want this to look the same way. So we know it's going to keep curving up that way. So again, you can see how it got 3 times taller. All right, so why don't you try this one? So yes, I know we've only done one, but set up a chart just like I did, and half the y values, and see what your graph is going to look like. So stop that and give that a try. All right, so here, example C, you've got a 2x squared minus 3. So the parent then is going to be x squared, which is 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. And I am going to, so this one's got this little minus 3 here on it. So what's going to happen is that our function is going to move down 3. So we're going to move it down 3 to start, so down 3. So that's going to be my new starting place. So I'm going to put a dot there. I'm going to start at 0, 0, which is where it typically starts, and move down 3. And then I'm going to 2 times the x squared and get 0. 2 times 1 is 2, 8, 2, 8. And when I graph it, again, I'm going to graph my x, and here's my y. So from my new starting place right here, I'm going to go 0, 0. I have over 1, so starting here, over 1, up 2, over 2, and up 1, 2, 3, 4, 5, 6, 7, 8. Back 1, up 2, and back 2, and up 8. And so there you got that really tall parabola that started off by moving down 3. All right, let's skip down to E. We aren't doing the cubic, so to switch that 3 to a 2 right there. So let's do that. What is the parent of this? There's a lot of stuff there, but it all boils down to that we got an x squared. So this is going to be an x squared, and what's multiplied times my function, negative 1/2. So negative 1/2 x squared is going to go here. All right, so which way does it move? This is inside, so it's going to move right 4. So notice we don't do any distributing or squaring. We just look at it. This moves right 4 and up 3. So we're going to write 1, 2, 3, 4, up 1, 2, 3. And we're going to put our starting point right there on that. Then let's fill in our values over here. So again, 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. And then we're going to multiply it by negative 1/2 times the y value. So that's 0, negative 1/2. Negative 1/2 times 4 is negative 2. Negative 1/2 times 1 is negative 1/2. And again, negative 2. So let's plot our x and new y values here. So we have, from our new starting place right here, 0, 0. We have 1 down 1/2. We have over 2 and down 1, 2. Then we have back 1, down 1/2, and back 2 and down 1, 2. So we have a graph that looks something like this. Take it all the way to the end. I want you to come back and do D for a try me. So try this one.